I hope you're all having a great morning. I am Mr. Ish. Thank you for joining me. We're looking here at half angle formulas. And these are important, very important trigonometric identities. These are also known as the power reducing identities. If you have something which looks like sine square x, you can utilize the half angle formula or the power reducing formula, and you can convert this into 1 minus cosine 2x over 2. This 2x here would be in a parentheses because it's affected by that cosine. If you have something which looks like cosine square x, then you have a 1 plus cosine 2x over 2. And notice the difference between the two. There's a positive in this and there's a negative in that. Apart from that, everything looks identical. Very quickly, our main focus here is a single good question, but let's look at this. If I were to ask you to do sine square x plus cosine square x, you know that's one of those very important trigonometric identities. It's always equal to 1. But you can utilize these half angle formulas to show it to be the case. You know sine square x is equal to that. You can write that 1 minus cosine 2x over 2. And then you know cosine square x is equal to what you see right there, the 1 plus cosine 2x over 2. When you combine everything here under a single unifying denominator, because there is, you have a 1 minus cosine 2x plus 1 plus cosine 2x. The minus cosine 2x and the positive cosine 2x cancel. You end up having 2 over 2, and you end up having exactly what you wanted, which is a 1. And this right here is a very good way to verify that this Pythagorean trigonometric identity is indeed good, and you can show it by this. But let's look at the main focus of this video. It'll be a rather interesting question, and I'll present that for you. The rest of the video will focus on us simplifying what you see over there. All of this represents a function. We can say y is equal to sine to the 4x and cosine to the 4x. You have a positive here plus, and you have exponents here with regards to the number 4. If you wanted to simplify this, you can use half angle formulas or the power reducing formulas, and I'll show you. You're seeing something over here which is sine square x, but it is squared because that's how you get the sine to the 4x. And likewise, you can do the exact same thing here, cosine square x, and then you square that. Now in each of those instances, you can bring in the half angle formula or the power reducing formula. You'll have a 1 minus cosine 2x over 2, and you know you can square that. And then you have a 1 plus cosine 2x over 2, and you can square this. Now you have the interesting task of opening all of this. You're looking here like a minus b whole square, a plus b whole square. Let's focus right here. When you focus here on this numerator, you'll have a 1, you'll have a plus cosine square 2x. But then you'll also have a minus 2 cosine 2x all over 4. Think about it. We have a minus b whole square, so you should have a square plus b square minus 2ab, which is exactly what I have. Now in this instance, we can do the exact same thing. You have an a plus b whole square, so you should have an a square plus 2ab plus b square. Here's my a square component, and here's my b square component, cosine square 2x. And now I'll do my plus 2ab, which will be 2 cosine 2x all over a 4. If you want, you can combine everything here under a single denominator, and you might as well. We can do everything right here, and we can adjust everything as we see. You see, we'll erase everything here with the denominator. We'll bring everything under a unifying denominator, which right here is my 4. Now you will see some things will come together. If this 1 and 1 come together, you'll have a 2. You have a cosine square 2x, and you have a cosine square 2x. That'll be plus 2 cosine square 2x. You have a minus 2 cosine 2x, positive 2 cosine 2x, which cancel out all of this over a 4, which is now what we have simplified to. But this right here is not our ideal expression. You have everything here with regards to 2's. If you were to divide everything, because we have multiples of 2's, we can simplify everything. We have a 1 over here, we have a 1 over here. I don't need to put a 1 over there, but I end up having this. So we end up seeing a 1 plus cosine square 2x over 2. Now this right here is not your final form, because you're seeing something here which can be impacted by the power reducing or the half angle formula. Think about it. We had a cosine square x here generate that, but we have a cosine square 2x, and it should generate something like that. But there's a slight difference. Here you have a coefficient of 1. Here you have a coefficient of 2. So how can you do that? I'll show you. Focusing only on this, you'll have something which will come out like this. But notice the difference. You'll have 1 plus cosine 4x over 2. And you know you still have all of this too. You have to understand this difference. When you're looking at a cosine square x and you do the half angle formula, you get 1 plus cosine 2x over 2. But here we don't have a cosine square x, we have a cosine square 2x, which creates that. Anyhow, you have a denominator you can do over here, over 1. You can do simplification here and common denominator. You'll have a 2 plus 1 plus cosine 4x all over 2, which is all over a 4. This 2 very well attaches itself with that, multiplies both of these denominators, multiply, and you get an over 4. Your final answer will be just this, 3 plus cosine 4x all over 4. If this right here represents your function y is equal to this, or f of x is equal to this, and this right here represents your function y is equal to everything you see over here, you were to graph them, you'll find out that there are two different expressions but representing the same function, because this graph and that graph right there would be identical. You can plug these into your online graphing tool and you'll see these indeed are identical graphs. But that right there is the half angle formulas at work, the power reducing formula, so keep them in mind. Again, perhaps for this question the most difficult part was this right here, cosine square 2x and generating that, whereas cosine square x generates just that. You have to notice the 2 over here and the 4 over here. And that's about it for this video. Thank you for watching. Have a good day.